All right, so we've got a whole stack of books and lectures here all about software security. We're going to try and break it all down, all the stuff you really need to know. And honestly, this stuff is way more interesting than it sounds at first.
Oh, absolutely. It's a really fascinating area. These days, it's not just about making software that works right. It's got to be safe to use, too.
Yeah, for sure. I mean, think about it. Like every single app on our phones, all the websites that we use, they could all be targets. If security isn't built in right from the start, well, that's when problems happen.
Exactly. And that's actually a really great point to bring up the difference between the traditional, like software development lifecycle, SDLC, and then the security development lifecycle, SDL.
Yeah, and our sources, they really stress this difference. So, like, what is it? Are we just talking about tacking on a couple extra steps for security checks, or is it more than that?
No, it's way more fundamental than that. It's a whole different way of thinking. Think about it like this, like you're building a house. The SDLC, that's all about getting the rooms right, the features, making sure everything's in the right spot. But the SDL, that's making sure that that house is built on a strong foundation, right? Got strong walls, solid locks on the doors.
Okay, so it's not just adding security features at the end. It's about making security part of the design from day one.
Exactly, yeah. And that's where this whole idea of the SDL comes in. It's a framework, that helps developers integrate security into each step of the whole development process.
And, our sources, they actually go deep into each of those SDL phases. They go from the initial security assessment all the way to like what you do after the software is released. Can we break down some of the highlights, the key parts of that?
Yeah, definitely. Let's take the architecture and design phase, for example. This is where things get interesting, I think, because it's all about threat modeling.
Threat modeling. That sounds like we're thinking like the bad guys here.
That's exactly it. We try to figure out, like, how could someone try to exploit the software? And there are frameworks out there, like STRIDE, which, by the way, stands for spoofing, tampering, repudiation, information disclosure, denial of service, and then elevation of privilege.
So for each of those, you're essentially brainstorming like all the ways that somebody could mess things up.
Yeah, yeah, exactly. And once you've got a handle on what those potential threats are, then you can start to plan and think about how you're going to stop them. So, for example, if you worry about spoofing, which is basically where someone's trying to pretend they're a legitimate user,
Yeah.
you can implement like strong authentication, like multi-factor authentication.
That makes sense. So it's like you're playing chess, trying to stay one step ahead of your opponent.
That's a great analogy.
Yeah.
Yeah, threat modeling, it's all about anticipating, thinking like an attacker so you can build those better defenses.
And so how do all the different development methodologies fit into this? Like we've got Agile, DevSecOps, our sources, they talk about them a lot. How do they all play into this?
Oh, they're crucial. Absolutely crucial. Like traditional waterfall development, it's kind of like if you were building a house, you build the foundation first, then the walls, then the roof, and finally you add in the security system. But the problem is if you're almost finished and then you realize, oh, the foundation's weak, going back to fix it, that's a nightmare.
So then Agile is more like you're building in modules, right? That you can sort of adjust, adapt as you go.
You got it, exactly. With Agile, you work in these short cycles called sprints. And security, it gets built into each one of those sprints. So it's much more flexible and you can react to change a lot easier.
And then what about DevSecOps? It almost sounds like Agile, but like on steroids or something.
Yeah, you could say that. It basically takes those agile principles and brings them into the operations side.
Yeah.
Just with DevSecOps, security is everyone's responsibility, not just the security team. It's all about that continuous integration and delivery of secure software.
So developers, operations people, security teams, they're all working together from the very beginning to build in security.
Exactly. Imagine a system where every time a developer writes some code, it automatically gets scanned for vulnerabilities, and then they do all these security tests. That's basically what DevSecOps is all about.
Okay, that's actually starting to make a lot more sense. So we've got the framework, right? The SDL for building secure software, and then all these different ways, these methodologies that kind of influence how we integrate security into that. But what about actually testing the software itself to make sure it's actually secure?
Oh, that's next, and that's a huge piece of this whole thing.
I'm all ears. Lay it on me. Tell me everything.
Well, there are all these different approaches to security testing, and each of them has its own strengths and weaknesses, like static analysis, for example. That's kind of like, when you proofread a document really carefully, looking for every little grammar error. But in this case, we're scrutinizing the code itself for security flaws.
And this is before the software is even running, right?
Exactly. You're just looking at the source code. You're not actually running it. Then you've got dynamic analysis, which is more like taking the software for a test drive. You know, you're seeing how it behaves in a controlled environment so you can try and spot those weaknesses.
So, like, static analysis is checking the blueprint, and dynamic analysis is taking the car out for a spin to see how it handles.
Perfect analogy. And then there's fuzz testing, and this is where things get a little bit wild.
Yeah, our sources definitely mention fuzz testing. It sounds like it's like you're purposely trying to break the software.
In a way, you are. Imagine you're bombarding your software with all this random data, invalid inputs, just trying to make it crash, trying to do something weird and unexpected. That's basically fuzz testing.
So, if your software can withstand all that chaos, that's a good sign, right? It means it's probably pretty solid.
You got it. Fuzz testing, it's really great at finding those sneaky vulnerabilities that other testing methods might miss.
You know, this is really making me realize just how much goes into building secure software. It's not just about, writing elegant code. It's about building defenses against a whole world of potential attacks out there.
And we haven't even touched on the tools that can help automate all these testing processes.
Tools. There are tools for this. Tell me more.
Well, think about like vulnerability scanners. They can automatically go through your code and look for known weaknesses. Or you got penetration testing tools. They actually simulate like real-world attacks to see if they can find any exploitable vulnerabilities.
So it's like having an army of digital security guards constantly patrolling your software, looking for any sign of trouble.
That's a great way to put it. These tools, they're absolutely essential for finding and fixing those vulnerabilities before the bad guys can exploit them.
You know what? This is all super fascinating, but I feel like we've just scratched the surface of this whole world of software security. Like, where do we even go from here? Okay, so we've covered, like, the SDL framework, right? We talked about all the different development methodologies and why security testing is so important. But there's got to be more to it than that, right? Like,
Yeah.
our source, they keep talking about compliance and best practices and stuff like that.
Oh yeah, those are absolutely critical. Think of it this way. You could build the most secure software in the world, but if it doesn't, follow the rules, if it doesn't stick to best practices, well, you're still opening yourself up to risk.
Right, because it's not just about, like, protecting the software itself,
Yeah.
right? It's also about the user's data, building trust, and making sure you're not breaking any laws.
You got it. Exactly. And that's where frameworks like OpenSAMM come in. It stands for the Open Software Assurance Maturity Model. And it's basically a guide for organizations to assess and improve their security practices.
Okay, so it's not like a specific tool or a technique. It's more like a roadmap for building a mature security program.
That's a great way to put it.
Yeah.
Yeah, OpenSAMM gives you this structured approach to figuring out where you stand with security,
Yeah.
helps you find those gaps, figure out what to improve, and implement those best practices across the board from like governance and strategy all the way to, development practices and testing methodologies.
So it's kind of like a checklist to make sure everyone on the development team is thinking about security, building that culture.
That's a good way to think about it.
Yep.
Yeah, OpenSAMM helps you move away from those ad hoc security practices to something more mature, more systematic.
Now, our sources also mentioned something called BSIMM. Is that another framework kind of like OpenSAMM?
Yeah, it is. BSIMM stands for the Building Security in Maturity Model. It's a little different from OpenSAMM, though, because it's based on observing like real-world security practices from hundreds of organizations.
So it's more data-driven, right? Like a snapshot of what's actually working out there in the industry.
Exactly. It gives you this benchmark to compare yourself against, Helps you understand how you stack up against other companies in your industry.
These frameworks sound really useful for organizations that are serious about security. But can we shift gears a little bit? Our sources talk about these zero-day attacks, and they make them sound pretty terrifying.
Oh, zero-day attacks. Yeah, those are definitely the nightmare scenario in the cybersecurity world.
Why are they so dangerous? Like, what makes them different from other attacks?
Well, a zero-day attack, it exploits a vulnerability that nobody knows about, not even the software vendor.
Yeah.
Imagine a hacker finds this secret backdoor in your software, and nobody else knows it exists.
So, like, someone's robbing your house, and they've got a key that you didn't even know existed.
That's a great analogy. And because it's unknown, most of your traditional security measures like antivirus software, they're they're usually useless.
So how do you even defend against something that you don't know about? That sounds almost impossible.
It's incredibly challenging, for sure, but it's not impossible. It's all about having this multi-layered approach. You got to combine proactive stuff like threat modeling, rigorous security testing, with the ability to respond really quickly when something does happen.
And our sources, they mention these multidisciplinary teams being super important in those scenarios. Like, what role do they play?
Well, when a zero-day attack hits, it's all hands on deck. You need a team with people who are experts in security research, development, legal, PR, even customer support. Everyone has a part to play.
It's like you're assembling a SWAT team, and each member has their own specialized skills to contain the damage and figure out a solution, right?
That's exactly it. Yeah, you've got your security researchers analyzing the attack, developers creating patches to fix the vulnerability, legal, making sure everything's compliant, PR, communicating with the public, and customer support helping users, stay safe.
So it's not just about fixing the technical problem. It's about managing the fallout and making sure that you don't lose the trust of your users.
You got it. Transparency is absolutely key in these situations. When a zero-day attack happens, being open and honest with your users is the most important thing.
Right. It's about acknowledging the problem, explaining what you're doing to fix it, and helping users protect themselves.
Transparency builds trust, and trust is everything, especially after a security breach.
Okay, so zero-day attacks they're a real threat, and it takes a whole team effort to mitigate the risks. But switching gears back to the SDL, can we dig a little deeper into that initial security assessment phase? Like, what's that all about?
Yeah, absolutely. Think of it like creating the security blueprint for the entire project.
So it's about setting those goals, right?
Oh.
Understanding the specific security needs, making sure everyone's on the same page from the start.
Exactly. You do a thorough risk analysis, figure out potential threats, and determine what security requirements you need to meet. You also define security milestones, establish metrics, create a communication plan.
So it's like laying the foundation, the groundwork for a secure software development process.
Exactly. And within this phase, privacy impact assessments, or PIAs, they play a crucial role.
PIAs. We haven't talked about those yet.
Yeah, PIAs, they're all about making sure that the software handles personal data responsibly, making sure it complies with all those privacy regulations out there.
So it's not just about protecting the software from being attacked, it's also about protecting the user's data and their privacy.
Absolutely. PIs help identify and mitigate privacy risks early on. It's about making sure that user data is collected, stored, used, and shared in a way that's, ethical and legal.
Like building in safeguards to make sure user data is treated with respect.
That's a great way to put it.
This whole conversation is really driving home the point that building secure software, it's a team effort. It's not just about the code. It's about having the right processes, the right tools, and the right mindset.
It is. And recognizing that security is an ongoing thing, You're always learning, always adapting.
Couldn't agree more. But wow, we've covered a lot of ground in this part of our deep dive. I'm really excited to wrap it all up, summarize the key takeaways, and then maybe even explore how all these principles can be applied to other parts of life and work in the final part.
Welcome back. It's the final part of our deep dive into the world of software security. We've covered a lot, haven't we? SDL, Agile, DevSecOps, zero-day attacks, even OpenSAMM and BSIMM. Phew.
It's been a journey, hasn't it? But honestly, even after all that, I feel like we've only just, scratched the surface.
I know, right?
Yeah.
It's mind-blowing how much goes into making software that's not only functional but also secure.
Yeah.
But before we wrap things up, I'm really curious about something you mentioned earlier about how these principles we've been talking about, they actually apply to more than just software development.
Oh, yeah. It's really interesting when you start thinking about it that way. One of the biggest things I've taken away from all this is how important it is to think about security right from the start, from the very beginning. It's like you wouldn't wait till you've already built the walls of a house to start thinking about the foundation.
Yeah, it's about anticipating those problems, not just reacting to them after they've already happened. And I can see how that applies to almost anything, really, not just software.
Oh, absolutely. Like if you're planning a marketing campaign or launching a new product or even just planning a family vacation, thinking about potential risks and putting those safeguards in place right from the start, that can make a huge difference. Yeah, it's all about being proactive, not reactive. Which kind of brings us to another big takeaway. Continuous learning, right? This whole cybersecurity landscape, it's changing all the time. So you've got to be paying attention, learning, adapting if you want to stay ahead of the curve.
Yeah, it's like an arms race for sure.
Uh-huh.
New threats are popping up constantly, so developers and security professionals have to be, super adaptable. They got to be constantly learning and refining their strategies.
And that's a lesson that applies to, I mean, every field, right? No matter what you do. Doctors keeping up with the latest research, teachers trying new teaching methods. It's all about being curious and staying engaged.
Totally. Another thing that's really stuck with me is like how important communication and collaboration are. In all our discussions about the SDL, it's so clear that developers, security teams, everybody involved, they have to be on the same page.
Yeah, it's about breaking down those walls between teams, making sure everyone feels responsible for security.
Exactly. And that's something you see in any team that's, doing really well. Software project, a scientific breakthrough, a creative project, it doesn't matter. Open communication and collaboration, those are essential.
We also talked about all the tools and automation that are used in software security, right? Like those vulnerability scanners and penetration testing software. It makes you realize just how much technology is changing every field, automating tasks, making things more efficient.
It's pretty incredible when you think about the possibilities from manufacturing to healthcare, finance, education. Tech is changing everything.
So just to recap some of the big takeaways from our deep dive. Be proactive, be adaptable, be collaborative, and, embrace technology.
That's a great summary. But before we go, I want to leave you with one final thought, something to think about.
Ooh, I love a good challenge. Hit me with it.
We've been talking about how these software security principles apply to, different areas of life and work. But what if we take it a step further? Like, how can we apply those same principles to ourselves?
That's an interesting idea. What do you mean by applying security principles to ourselves?
Well, just like software can be vulnerable to attacks, we as people, we're vulnerable too, right?
Yeah.
To negative influences, to bad habits, even to our own self-doubt.
So you're saying we can use these security principles to kind of build up resilience, protect ourselves from those negative things.
Exactly. Like the same way we build security into software by thinking about threats, putting safeguards in place, adapting. We could do that for ourselves too.
Like building our own internal security system to protect our mental and emotional well-being.
Exactly. So, as you go about your day, think about how you can apply those lessons we've talked about. Be proactive, be adaptable, and don't be afraid to, ask for help, collaborate with others when you need to.
This has been such an eye-opening journey into software security. We've learned so much from all the technical stuff to like the bigger picture of how to create a secure digital world.
It's been great exploring all this with you. And remember, security, it's not a finish line. It's a journey. Keep learning, stay curious, and stay safe out there.
Thanks for joining us on this deep dive. Until next time, keep exploring.